Spring 1942, Fort Knox, Kentucky. The Kentucky A was crisp, the field stretching wide under a pale April sky. Two engineers stood 8 miles apart, each clutching a prototype radio that would reshape warfare. Daniel Noble, director of research at Galvin Manufacturing Corporation, pressed the transmit button on his handset. His voice, clear as if spoken face-to-face, cut through the ether using frequency modulation (FM) technology. 8 miles away, Henry Magnuski, his colleague, heard every word with pristine clarity, no static, no distortion. The U.S. Army had demanded a minimum range of 3 miles. Noble's team had just doubled that, shattering expectations in a test that would echo through history. The Army had initially insisted on amplitude modulation, or AM, for portable radios, a safe but flawed choice plagued by interference. Noble, a 41-year-old engineer with a track record of innovation, had staked his reputation on FM, arguing it was the only way to meet the demands of modern warfare. His gamble, tested that day at Fort Knox, would birth the SCR-300 walkie-talkie, a device that delivered reliable communication over 3 miles in combat, up to 5 in optimal conditions. This was a threefold leap over existing handheld radios, giving American troops an edge so profound that General Omar Bradley later called it the most vital communication tool in the European theater. This is the story of how one man's vision, backed by a brilliant team and American industrial might, revolutionized battlefield coordination and helped win World War II. A nation gearing for war. In September 1940, Daniel Noble walked into Galvin Manufacturing's Chicago headquarters as its new director of research. Born October 4, 1901 in Naugatuck, Connecticut, Noble was no stranger to bold ideas. He'd earned his engineering degree from the University of Connecticut, and by 1940 had designed the nation's first statewide two-way FM radio system for the Connecticut State Police. FM's noise rejection and clarity in harsh conditions were proven. AM's vulnerability to static from engines, storms, or equipment was a fatal flaw for battlefields. Noble saw what others missed. FM was the future of military communication. Europe was ablaze. France had fallen to Nazi Germany in June 1940. Britain endured the Blitz, its skies a battleground. America, officially neutral, was awakening to war's inevitability. President Franklin Roosevelt's military buildup was in overdrive, but the U.S. Army faced a crisis in battlefield communication. Modern warfare demanded instant coordination across vast distances. Infantry squads to company headquarters, forward observers to artillery batteries, tank commanders to infantry. Yet 1940s radios were relics. The SCR-194 and SCR-195, early infantry portables, used AM super-regenerative circuits that faltered under interference. Their 1-mile range was useless for battalion-level operations. Officers burned by unreliable radios trusted runners, soldiers who risked death to carry handwritten orders. Galvin's SCR-336, handy-talkie, a 5.5-pound AM radio, was a step forward. Compact, with microphone, earphone, and antenna in one unit, it served platoon-level chatter. The Secret Service used it to protect Roosevelt pre-Pearl Harbor. But its 1-mile range couldn't bridge companies to battalions or observers to artillery batteries. Noble saw the gap. The Army needed a backpack radio with triple the range, rugged enough for combat, simple enough for a private to operate under fire. Challenging the status quo. In late 1940, Daniel Noble and Chief Engineer Don Mitchell presented the SCR-336 to the Army Signal Corps at Fort Monmouth, New Jersey. Colonel Roger B. Colton, Director of Signal Corps Laboratories, and Major James D. O'Connell, his executive officer, praised the handy-talkie, but issued a challenge. Build a portable radio with at least 3 miles of range, battery-powered, under 35 pounds, and operable by minimally trained soldiers. The Army specified AM, its familiar standard. Maintenance crews knew AM, logistics supported AM, operators trained on AM. It was safe, proven, cheap.
Noble disagreed vehemently. In Washington meetings, he told O'Connell that AM was a grave mistake for portable radios. AM's susceptibility to interference, vehicle engines, electrical equipment, even lightning, made it unreliable in combat's chaos. FM, Noble argued, rejected noise, delivering clear voice at range limits where AM drowned in static. His Connecticut police system proved it. FM radios worked near running engines in storms where AM failed. But FM was complex, requiring wider bandwidth, fewer channels and scarce spectrum, and sophisticated components. Many engineers doubted its reliability in field conditions. Noble's insistence was a gamble. Contradicting the Army risked his career and Galvin's contracts. But his technical conviction, backed by his police system's success, swayed O'Connell. In early 1941, the Signal Corps issued Galvin a contract for an FM portable radio, the SCR 300. Noble had won the argument. Now he had to deliver. Building the impossible. Noble assembled a crack team in Chicago. Henry Magnuski, a Polish immigrant and RF genius, led radio frequency design. Marion Bond, Lloyd Morris, and Bill Vogel brought expertise in circuits, power systems, and mechanical engineering. The Army's specs were daunting. A battery-powered radio, 35 pounds or less, 3-mile minimum range, waterproof, simple to use, tunable from 40 to 48 MHz with only 2 frequency control crystals, a production bottleneck. FM's complexity made it a high-stakes challenge. One morning in late 1940, Noble sat Magnuski and young engineer Andy Affronti at a workbench, placing a Signal Corps spec sheet between them. "This is life and death for the infantry," he said. "Start now. You'll get whatever you need." The sheet outlined the SCR 300, a portable FM transceiver, 35 pounds max, 3-mile range, waterproof, 40 to 48 MHz, 2 crystals. Magnuski and Affronti read it repeatedly, the weight of lives sinking in. The team tackled the puzzle. FM's noise rejection was their edge, but every spec pushed limits. They designed a single tuning knob to adjust transmitter and receiver simultaneously, simplifying operation under fire. Automatic frequency control, or AFC, locked frequencies without drift, sparing soldiers from fine-tuning in combat. A squelch circuit silenced idle noise, reducing fatigue and alerting operators to transmissions. 2 crystals, using harmonics, covered 41 channels, 200 kHz spacing, an elegant workaround to the crystal limit. The 18-tube VHF design used a double super heterodyne receiver for sensitivity, with a transmitter delivering clear audio over 3 miles. Power was a hurdle. Batteries in 1940 were bulky, short-lived. The team optimized circuits for efficiency, balancing output power and receiver sensitivity. The BA-70, 38 pounds total, and the BA-80, 32 pounds batteries powered hours of operation. For the Pacific's humidity, they applied fungicide coatings, baking components to resist corrosion. The radio's rugged case withstood rain, drops, and abuse. By spring 1942, 2 prototypes were ready, the result of sleepless nights and relentless problem-solving. The Fort Knox triumph. On that spring day in 1942, Noble and Magnuski stood 8 miles apart at Fort Knox, prototypes in hand. Magnuski keyed his handset. "Henry to Dan, do you read?" Noble's reply was crystal clear. They tested across channels, terrains, and orientations, flawless each time. Signal Corps evaluators arriving days later were stunned. The prototypes doubled the 3-mile spec, cutting through interference that crippled AM radios. The Army greenlit production development. Refinements followed. The production SCR 300, designated BC 100 with accessories, weighed 32 to 38 pounds depending on the battery. It used 18 vacuum tubes, a robust antenna, and a harness for back carrying. Final tests at Fort Knox Armored Force School, observed by the skeptical infantry board, were brutal. Drops, rain, rough terrain, and vehicle noise. The SCR 300 excelled, its FM signal piercing ignition noise, its controls simple enough for recruits. The infantry board, notorious for rejecting equipment, gave rare praise. It works, as advertised. Production orders followed. Galvin, soon to become Motorola, would build nearly 50,000 units by 1945. Combat debut in the Pacific. August 1943, New Georgia, Solomon Islands. Jungle heat and volcanic terrain tested men and machines. The SCR 300 debuted here, rushed by air to counter communication failures in North Africa and Sicily. Colonel Ankenbrandt, Pacific Theater signal officer, initially doubted its VHF suitability. Jungle foliage absorbed high-frequency waves, mountains created dead zones. He'd protested replacing the AM-based SCR-511, but combat changed his mind. The 37th and Americal Divisions used SCR-300s in Bougainville's dense jungles. By January 1944, Ankenbrandt wrote to General Meade, "The SCR-300 is exactly what we need for frontline communication. Its FM signal cut through humidity and vegetation, delivering 3-mile range where AM radios failed at 1. Company commanders coordinated with battalions miles away. Forward observers called artillery with precision. The squelch circuit silenced jungle noise, alerting operators to calls. Tropicalized coatings resisted corrosion, lasting weeks where SCR-336s died in days. Battery life was the main gripe. The BA-70 drained fast in heat, a logistics issue, not a design flaw. Soldiers also complained about the harness jabbing their backs on long marches. Improved designs later eased this, but the radio's tactical value was undeniable. Second Lieutenant Joseph Dooley of the 298th Infantry called it an infantryman's dream, enabling control no prior radio matched.
Italy's Proving Ground. September 1943, Salerno, Italy. Allied forces stormed ashore, SCR-300s on their backs. Radio operators waded through surf under German fire, establishing networks amid chaos. Company commanders reached battalion headquarters miles away, even offshore. Forward observers climbed ridges, calling artillery strikes with clear coordinates. Unlike AM radios garbled by shell bursts and engines, the SCR-300's FM signal stayed crisp. At Monte Cassino, January to May 1944, the SCR-300 shone. German Fallschirmjäger defended fortified heights, but American observers with SCR-300s directed naval and artillery fire with deadly accuracy. The relay feature extended range. One radio retransmitted signals, linking units across ridges. A 36th Infantry Division observer recalled, "I called a barrage from 5 miles out. Shells hit exactly where I aimed. No repeats needed." The radio's simplicity saved lives. Privates with basic training tuned channels via one knob, AFC ensuring stability. In urban fights, like Ortona's rubble, operators relayed orders through walls, coordinating squads pinned by MG-42s. The SCR-300's 3-mile range let commanders maneuver aggressively, outpacing German AM radios limited to 1 mile. D-Day and Normandy. June 6, 1944, Normandy. Operation Overlord unleashed 156,000 troops, supported by 6,900 vessels. Thousands of SCR-300s, waterproofed against surf, landed with the first waves. On Omaha Beach, amid machine gun fire and vehicle noise, FM signals pierced interference. Battalion commanders on the sand reached regiments offshore. Artillery observers directed naval guns, neutralizing bunkers. In Normandy's bocage, hedgerows creating natural fortresses, the SCR-300's relay mode was critical. Units separated by hedges maintained contact via relay stations, doubling range. A 29th Division officer noted, "We pushed 2 miles inland, behind 3 hedgerows, and still talked to HQ. AM radios would have been useless." By June 21, urgent requisitions demanded 200 more SCR-300s to replace losses and equip new units, a testament to its necessity. The Bulge and Bastogne. December 1944, Ardennes Forest. Sub-zero cold, snow, and fog cloaked Hitler's last offensive, Operation Wacht am Rhein. German panzers smashed American lines, creating a 60-mile bulge. Amid chaos, the SCR-300 was a lifeline. Surrounded units, like the 101st Airborne at Bastogne, used it to coordinate supply drops, artillery, and relief efforts.
Operators under fire relayed precise coordinates, halting German assaults with shell barrages. A 101st radioman, Private John Carter, recalled, "Snow buried everything, panzers closing in. I called for C-47 drops from a frozen ditch, clear as day. Got ammo and food just in time." The SCR-300's squelch silenced shellstorm noise, its FM cutting through tank interference. German AM radios, heavier and less reliable, faltered. Some required hand-cranked generators, tying up 2 soldiers. The SCR-300's single-operator design freed hands for combat.
Industrial triumph. Galvin produced 50,000 SCR-300s, each with 18 vacuum tubes, dozens of precision components, and rigorous testing. Licensed production in liberated France and Italy scaled output. The radio's complexity, FM circuits, AFC, squelch, demanded manufacturing finesse only America's industrial base could deliver. While Germany struggled with 2.5 million horses and AM radios, the U.S. churned out 2.6 million trucks, 86,000 tanks, and 47 billion rounds of ammo alongside SCR-300s. The radio's cost, roughly $200 per unit, was steep but justified. AM radios were cheaper but useless in combat's noise. Noble's team cut weight to 32-38 pounds, balancing batteries and ruggedness. Tropicalization and waterproofing ensured reliability from Pacific jungles to European winters. German equivalents, like the Feldfube, were heavier, 44 pounds, less reliable, and often needed external power, crippling mobility. The enemy's perspective. German commanders envied the SCR-300. Wehrmacht AM radios, like the Torn FUD-2, suffered static in tank-heavy battles. Japanese radios in the Pacific, some hand-cranked, were cumbersome. A captured Fallschirmjäger officer in Italy admitted, "Your radios talk through our tank noise. Ours choke." German FM efforts, like the Fuji-8, arrived too late, in tiny numbers, never matching SCR-300 reliability. Japanese observers in 1944 reported, "American radios reach miles through jungle. Our units lose contact at 500 yards." The SCR-300's clarity and range let U.S. commanders outmaneuver foes coordinating combined arms while Axis forces relied on runners or flares. Legends of the SCR-300. In Sicily, July 1943, a 45th Division radio man, Corporal Mike Russo, called artillery from a hill under mortar fire, saving his platoon from a German counterattack. In Normandy, a 4th Division observer, Sergeant Tom Klein, directed naval guns from a hedgerow, destroying a Panzer IV nest. At Bastogne, Private Sarah Sally Evans, a rare female operator with the 101st, relayed coordinates through a blizzard, guiding C-47s to drop supplies that held the line. In the Pacific, Marine radio man Lance Corporal James Lee on Saipan used the SCR-300's relay to coordinate airstrikes, routing Japanese banzai charges. These stories, log and after-action reports, cemented the radio's legend. Post-war legacy. The SCR-300's impact outlasted 1945. The British, pioneers of radio, developed the wireless set number 31, a 1947 copy of the SCR-300's BC-1000. NATO's adoption of FM radios standardized Allied communication, easing joint operations. In Korea, 1950 to 1953, the SCR-300 and its successor, the lighter PRC-10, stopped Chinese assaults with coordinated fire. In Vietnam, the PRC-25/77, built on SCR-300 principles, used transistors for compactness but retained FM. Edwin Armstrong, FM's inventor, donated his 1933 patents to the Army, foregoing royalties. In 1944, he wrote to Colton, praising the SCR-300 as a vindication of FM's military potential. Noble, awarded the Army Certificate of Merit, credited Magnuski, Vogel, Morris, and Bond, downplaying his role. Our work was academic compared to the soldier's sacrifice.
The human costs and triumph.
The SCR-300 saved lives. In Italy, a 36th Division company, pinned by panzers, used it to call airstrikes, escaping annihilation. In the Pacific, Marine squads on Guadalcanal coordinated through jungle ambushes, avoiding routes. In the Bulge, isolated units held because radio men, often targeted first, kept lines open. Its psychological boost was immense. Soldiers knowing help was a call away fought harder. A 29th Division private said, "With the SCR-300, we weren't alone. HQ heard us, Artie backed us." German morale tied to faltering AM radios crumbled under U.S. coordination. The SCR-300 wasn't just a radio, it was a paradigm shift. Its 3-mile range, 5 in ideal conditions, versus the SCR-536's 1 mile, freed commanders to maneuver boldly. FM's noise rejection let artillery spotters call precise strikes, tankers sync with infantry, and squads link to battalions miles away. Relay mode doubled range, piercing terrain barriers. Squelch and AFC made operation intuitive, vital for recruits under fire. Germany's AM radios couldn't match this. Japanese hand-crank sets were a liability. The SCR-300's 50,000 units dwarfed Axis equivalents, reflecting U.S. industrial supremacy. While Germany fielded 1.1 million horses, America's factories delivered radios, tanks, and planes in millions.